Hello, my name is Tom Jones. I am the program head for Electrical Systems Technology here at Randolph Community College. We have enjoyed the day and we appreciate you coming to be with us. What we wanted to do today was talk to you a little bit about what we do, what we train for, options, money, types of careers, things like that that are available here at Randolph Community College. First of all, I'm going to start with electrical systems technology. Electrical systems technology is what I've been in charge of for going on 10 years now. Electrical systems is a commercial / industrial based program area, but it also has a residential component. Today we're in the residential wiring lab. These booths behind me that you see, they're for student work. We do a lot of hands-on in our program areas, so just for informational purposes, a lot of people ask, is there any hands-on? We are more than 60% hands-on with our training so that you guys get the best we can give you. We train you to be good at what we do as best we can. We actually have a good rapport with many companies in the area. You can come to school, you can earn a wiring certificate, a certificate in programmable logic controllers, a diploma, or a degree. So you can earn a lot of different things while here. There's other certifications or credentials you can earn as well in robotics. So in electrical systems currently we have things that we do, and what you're in right now is what we call our residential wiring lab. This is one of the first classes you take while here. This gives you a springboard to a lot of other things. This is probably our most simple and elementary thing that we do. So that's why we put this first. It also gives you a whole lot of stuff that you can use at your house if this is not what's up for you. We have multiple careers available in the electrical world. There's a residential electrician, commercial electrician, industrial electrician, industrial maintenance, and electrical. We also have low voltage so that we can do fire alarms, security, access control, sound, paging, those types of operations. Does it all require a license? The answer is no. You can work for a company that has a license and you can be an assistant or mechanic or a helper or something like that. You can work for a company, an industrial company, and you don't need a license. A lot of people come in with the misconception that we train to give you an electrical license, which is not possible. You're required to have many thousands of hours of on-the-job training before you can get a license. So what we try to do is get you to a point where when you go to work in that first job after graduation, you can be successful, be safe, be smart, and not get hurt. Because as most people know, electricity is dangerous. So we try to make sure that you leave here with a good, solid safety standpoint on electricity. So those are job titles you can have. We work with companies throughout the area and some in Greensboro, and I have one company out of Raleigh that we work with to get people jobs. So when we're looking at job opportunities, most of our folks who graduate with a degree generally have employment by the January prior to their graduation. They're looking at anywhere from a $14 an hour start pay all the way up to $24 an hour, depending on where they want to go. So that's just starting pay. That could be up to $30 an hour within a few short years, once you get some good experience in the field that you end up in. There's a lot of different directions you can go with this degree, so there's a lot of different opportunities that give you a lot of different wide range in pay and a lot of different skills. So that's where we are looking at as far as why the pay scale is so wide. The other curriculum that we offer here is something called industrial systems. and we'll get more into the industrial side of things a little later, but it's more industrial based. If you want to be a person that works in a manufacturing environment, we have that option also. Those starting pays are around 18 and they go 18 to 24. So when we are talking about these careers are wide open. There are more jobs than we can fill. At one point, I had 60 job openings and 15 graduates. So that gives you an idea of the differences that we have going on. We actually average 1 to 2 calls a week. You have anybody we can hire. And that is growing. In the electrical industry, most of our electrical contractors are retiring. So there's a dire need for new folks in the contracting field. Yes, it takes about 3 years for you to be eligible to sit for a licensure exam to be a contractor after you leave here. But once you leave here and get your 3 years, then you can run your own business. That's a possibility. So we're looking at down the road trying to make sure that we fill the needs of the people. The needs of the people would be places to come to school to get good education and places to go to work. And I think we can do quite well with that. So I thought we would start here since this is our one of our springboard starting points for our electrical systems. So what's taught in here is residential wiring. So each one of these booths is set up so that you can learn to wire your light switches, your receptacles, your overhead, what we call recessed can lights, all those kinds of things. And also at the end of the day, we do some bigger stuff, but that's in another part of the room where we have different things set up. But your final exam would be able to wire a complete room by yourself. If there's anything that you see that you question or interest you, this would be something fun. It's also a very fun program to be in because we do so much hands-on. What I thought we'd do is I thought we'd go from here to another location where we have some other things where we do some other things. Hey, okay, here we are. We're in our what we call our electronics lab. In our electronics lab, we do some fundamental classes and we do some upper level classes. I'm standing beside what is now a final project for a class on fire alarm and cabling. These students have gone through and wired all these devices like they would be in a commercial building. And our next little adventure next week is to actually program via Ethernet IP network this panel to function with all these devices. So that's our next week's adventure. In this class we teach a lot of different topics from fundamental DC and AC electricity to industrial electronics and those kinds of things. If you notice over to my right, I have some workstations set up. These workstations have it looks like a black box. These black boxes are made by a company called NIDA Corporation out of Melbourne, Florida. These are the same black box trainers that the U.S. military uses for the Marines and the Navy. So these setups here are for student work. We actually work in here. We have a lot of learning goes on in this lab as far as what is happening. We spend a lot of time training. We spend a lot of time hands-on. And some of our, what you might call chalk talk does happen in here under the guise of the fundamentals class. Our non-fundamentals classes, our upper level, is more hands-on based. So what you're looking around at is a classroom that is a full functioning lab as well. So we do a lot of our classes in here, and as you can see, there's a lot of things to learn, put your hands on, and learn how to operate. A lot of people get kind of scared when they look around, but don't be. We do it just like if you were eating an elephant, one bite at a time. So don't panic. This is a good place to learn. we're going to be moving now to what we call our motors, controls, and fluid power lab. Here we are. We're in our one of our labs where we use a lot of equipment to do a lot of expensive things that are really good. This lab is used for learning to read blueprints. This lab is used for motor and controls. This lab is used for hydraulics, pneumatics technology, and it's used by both electrical systems and industrial systems for what we do. As you see beside me, these are some of our motor control trainers, and these are what students will work with. We have variable frequency drives. They're used to control the speed of AC motors. We have all the controls on here to control electric motors. So we have these things over here to my right. This is what it might look like if you were in an industrial plant and that you were opening a cabinet that does those controls. So this one is something that students have wired, and they're of course learning to wire reading prints. They will be provided a print by their instructor on what to do. We spend a little time going over the symbols that are on the prints because it doesn't say put wire here to wire here. It's got we use pictures. Here in the electrical world, we love pictures. We also love crayons too, but that's another story for another day. But we love pictures. We draw a lot of pictures. We spend most of our life in pictures. There's symbols for this. There's symbols for this. And over here, we have a pneumatics training station, and matter of fact, this semester I am teaching the pneumatics portion of the class, and so we've been using this so far this semester. They just finished up their final test on the pneumatics. Now, what their final test consisted of was me giving them here's some symbols, here's what I need this to do. You need to draw me a schematic of using the symbols that I've given you, and then I need you to make it work. And so this was what they had to work from. They had hoses. They used compressed air off of a compressor system we have. And so they actually used all this stuff to pass their test yesterday. So this was what we did for a test. Our tests are not read a book and pick A, B, C, or D most of the time. Most of our tests are hands-on proficiency. You know, that's the best way people learn. So we have all these different devices that you can find in an industrial environment. So that's why industrial systems, electrical systems, we make sure that you can handle this. Even though it's not really electrical, there's other devices that can be piggybacked onto these to be controlled by electricity and electronics. So we get you the fundamentals, and then later on down in the semester we get with the fancy stuff that you control with something called a programmable logic controller, which will be our next stop here in just a second. And here we are, we're in what we call our PLC Lab. PLC stands for Programmable Logic Controller. A PLC is an offline, standalone computer that can do many, many functions very fast. This is the heart and soul of a lot of our manufacturing environment today. But to my right here is a student project. If you look up a little bit, you might be able to see these are the drawings the student is using to make all the connections before writing the program to make this function work. What we're doing here is we're actually filling cans, you know, like drink cans. It's a can filling operation. So it's everything from putting the can on the belt to filling the can to making sure the can's full to putting the lid on the can. This is all possible with this one piece of equipment. This is called a work cell. Many, many factories in this area, and since we are the 6th most industrialized county in the state of North Carolina, they use work cells every day. What you see in this room is our PLC lab. These are the controls that the students learn on before they go to work in a manufacturing environment. Whether they be electrical systems or industrial systems, you still need to know this. If you are going to work and say, I want to be an electrician, that's fine. But if you're an electrician and you go to wire up a chicken house, for example, you'll still have to deal with these. because they control everything in the chicken house, from feeding the chickens to turning on and turning off the lights. It's fully automated now. Nothing is, flip a switch and turn the lights on, get a bucket and feed your chickens. It's all done with equipment and automation. This automation you learn about the networking that it takes to transmit it. You learn about the computer programming, the wiring. You've heard of information technology. What you're seeing here is something we call operational technology, because it controls machines and equipment. Where we'll be going shortly for electrical systems and industrial systems is what we call our manufacturing lab. Over there we got some pretty cool toys as well, but I thought you needed to see this before you saw what we could do with these toys. So with that, we'll go to the manufacturing lab. Here we are in our manufacturing technology building. This is where we have program areas taught for about all three programs that we have here at RCC. I'm focusing today on electrical systems and industrial systems. You'll see to my right, you'll see something that looks like a pneumatic trainer, and it is. It's a full functioning system. You'll see some conveyors. They actually tie into this cage that's behind me for a full functioning injection molder to make parts. We actually have robots back here that we can use for pick and place and controlling. I've got the FANUC, which is the most common robot for material handling in Randolph County, and these are true industrial robots. We don't, and the question I get asked most often is, do you build robots? No, we really don't. What we do is we train you on how to use them, set them up, program them, and troubleshoot and repair them. And that's what our main focus is whenever you guys leave us, that you are capable of going and not being afraid to open the cabinet and work on one of these things before you leave, we hope. We do offer certifications. We do offer, and not just the certifications that are sponsored by Randolph Community College. We offer like a certificate, a wiring certificate, from our last visit with the PLC Lab, a PLC certificate. But FANUC, I'm a certified robotics trainer for FANUC, and we can offer you certification through FANUC America. FANUC is actually made in Japan at the foot of Mount Fuji. And so if you've ever watched that movie Terminator, where robots are building robots, that really does happen at the foot of Mount Fuji. There is no employees working in that plant. All they do is once a month they turn the lights on, they take out the finished product, which are these machines, and they put in raw materials and lock the doors, turn out the lights, and go home. So that does really exist in our world. It just happens to be in Japan, where they make the FANUC materials, like the FANUC robots, the robo drills, things of that nature. Epson over here, which is these little white robots, they're made a lot for high speed on a conveyor belt for sorting, picking, reorienting parts as they come out of the production environment. Those are very fast little, what we call SCARA robots. And so SCARA is a compliance robot that actually works really fast. Its main claim to fame is pick, place, sort, and twist. And they work off of cameras. These robots, especially the one right here in front of me, as we're moving along, you can see that this camera can do part inspection down to 1/10,000th of an inch. So these cameras are really good. This is a banner light with a Sony XC56 camera. We can put a part here and we can inspect and measure with this camera, because it's a 4 megapixel digital camera. So not only can we tell what the part is, what it looks like, we can tell how it's twisted, we can find defects in the part. That is a quality control issue in a lot of manufacturing. So that's what those cameras do. So we're going to move around here in just a moment. So I thought we would move over to another part of this building where we do in our manufacturing and our industrial systems, we have a class or two on machining and machine shop fundamentals. So I thought we'd check that out in just a second. Here we are. We're in we're still in the manufacturing technology building, but we're in our machining area. We have some classes in our industrial systems where you would learn to run these types of machines to make parts. In a manufacturing world, sometimes you have to make your own part. You can't necessarily buy it at Amazon or somewhere else. So you have to make your own stuff. So these hands-on skills of fabrication come into play. So this is what we call a vertical mill. It's 3 axis, so it can go left, right, forward and backward, and up and down. So it's 3 axis. And then over on the other side over here, we have what's called a lathe. It's a turning device which can take a piece of metal that's round and we can make stuff, or we can take a square piece of metal and drill round holes in it, make threads, cut a pocket in it. Stuff like that can be done with the lathe. This area here is where we learn some of our fabricating skills for things we can't buy or we can't get, or that sort of thing. So those skills are necessary in the industrial systems world as much as anything else, because things that break you don't always have a spare. So this is how you learn to make your own. And so from here we're going to go to where we do some of our mechanical skills. Okay, we're over here in the area of the manufacturing technology building where we do our mechanical skills. That includes gears, pulleys, bearings, motor alignment, shaft alignment, which I'm doing with my students next week. We also have some hydraulics that we'll do to drive motors and things like that. So this is our mechanical area. Our students down here, they actually learn to connect things using gears, pulleys, drive, chains. Kind of like a chain on your motorcycle or your bicycle, something like that. Over here, you see a gray cabinet on the wall to my right. We are working, we have a class on renewable energy. So we do some solar energy here as well through the electrical systems technology, if that interests you. Our electrical systems right now, we're doing what's called a solar hot water collector, where we're going to be collecting the sunlight to heat water, and we're going to be charting it. You'll see those square boxes, those are ABB chart controllers. We'll be able to chart how the water heats through the sun and cycles and circulates. We'll be controlling that through what's behind that door. We have a programmable logic controller and several other things that are behind that door to actually do controls. So there'll be some wires coming out, going outside to our solar collector. We also, the cool part is, this whole thing is solar powered. So we're making our own power to circulate our own hot water. So we've got solar panels sitting out there making power now, going to a set of batteries in that cabinet on the door to the right here, where we actually are making power to make the power to run our solar hot water. So we're totally off-grid, totally standalone. So it's kind of a lot of fun to do that. We're doing our pipe work now to try to get so we can have a lot of hot water for the summer, hopefully before it gets too cold, because we're having to do our pipe work stuff outside. Now, just follow with me, and I'm going to walk you around to show you what's called a injection molder. An injection molder makes plastic parts. This injection molder in here, what happens is we take plastic pellets, and they come through these what look like vacuum cleaner hoses and come into what we call the injector nozzle. It gets heated as it goes from here to here. It goes from room temperature to 444 degrees. Once it comes there, it comes into what we call the press, which is 2 plates of metal with a form inside, where we're keeping those cool with water through a refrigeration system, so that when that hot plastic is shot into that mold, it makes a pretty nice looking molded plastic product. And then when it opens, the mold here opens, and we've got some things sort of pulled closed, so that's about as far as I can do with the door. But when the mold opens, you see I have a robot sitting here on top of the mold. It will go down and get that plastic part and kick it out the other side, with the possibility of cutting off what we call the sprue. So if you'll follow with me just a second, I'm going to walk over here and grab a piece of plastic that we've made. This is a drink coaster. This one here didn't get the sprue or the plastic leftovers cut off, but this is a drink coaster with Randolph Community College on it. Hopefully we'll be able to get some video of this machine running shortly. So thank you for listening. We really hope you come down and sign up. And if you are interested in electrical systems, or if you're interested in industrial systems, please feel free to contact me, Tom Jones, or my coworker, David Dower, at 336-318-0496. And we will be happy to discuss with you the ins and outs of becoming a student and what this benefit will be to you.